Hello friends. So today we are going to discuss about ESR spectroscopy. So what is meant by ESR? So Electron Spin Resonance. So we are going to see about the theories of ESR, instrumentation, derivatives, curves, G-shift. First of all, we discuss about what is an electron spin resonance, ESR. Definition: it is a branch of absorption spectroscopy in which radiation have frequency in microwave region absorbed by the paramagnetic substance in due to transition between magnetic energy level of electron with unpaired spin. Another, the electron spin resonance ESR spectroscopy is also known as Electron Paramagnetic Resonance. We call it as a EPR. So it is absorption spectroscopy similar to NMR, possible only with molecule having unpaired electron. NMR used as a radio waves, but here we are used is microwave. ESR range 9000 to 10,000 megahertz. Here we are used. So this is the particular useful for the studying of metal complex or organic radical complex. So this is a very important ESR spectroscope. So instrumentation of ESR is very important. The instrumentation is involved in source. The source means microwave radiator, attenuator, waveguide, sample cavity, electromagnetic modulation coil, phase shifter, crystal detector. So these are important parts in instrumentation. First of all, we are discussing the source. Clay star tube. It's a very important source. It is used as a source of the radiation. Microwave radiation is typically produced and amplified by the klystron tube. It is capable of running waves to previous frequency, amplitude and the phase. It's a very important klystron tube. So electron pathway, anode, negative reflector electrode. These are the many important, the heater filament also involved in this source. Attenuator, it is used to adjacent level of the microwave power. So we are using the microwave power, very important. The waveguide, it is used to convey the microwave power to the sample cavity. What is sample cavity? It is constructed and placed between the maximum magnetic field. The most of the ESR have the dual sample cavity. So one is for the sample, another one is for the standard material. So electromagnetic, here ESR spectrum have the recorded by the slowly varying the magnetic field through the resonance condition by the current supplied magnetic field by power supply. So both the power supply and magnetic need water cooling system. So this is for the electromagnet. Another one important, modulation of Kopff coil. The variation of magnetic field is produced by the supplying AC signal to modulation coil oriented with the respective sample. Another, the phase shifter. This can compensate undetermined phase difference which may be introduced in the amplification stage of the spectrometer and oscilloscope. So this is for the phase shifter. Another, the crystal detector. The most common used detector is silicon crystal detector. This act as a rectifier. This detect the electron spin transformation. Crystal detector is very important, the instrumentation technique. Here the theory of ESR. ESR is a phenomenon resulting from the coupling between the magnetic field such as and the spin of the molecule electron. So NMR is having the spinning of the proton, but ESR having the magnetic field and spin of the molecule electron. It is based on the magnetic resonance of unpaired electron spin species. The magnetic resonance of unpaired electron spin. The radiates with the microwave radiation. The NMR having the radio frequency, but here the microwave radiation is important. Then it can undergo the transition from the one spin to another spin. One spin to another spin. It means to beta state to alpha state. So NMR also we are discussing of. So low level and higher level. We are talking about here the beta state and alpha state. The paramagnetic species like free radical, biradical or multi-radical conduction of the electron in metal, transition metal and complexes. So this theory is very important to predict the paramagnetic species like free radical, biradical and multi-radical. So already you know that the radical means odd electron. So it is the main involved in metal transition as metal complexes are involved in this spectrum. Then When the atom or nuclear system is with the unpaired electron is subjected to the magnetic field, electron energy level of the atom or molecule will split into different level. So we are discussing the unpaired electron is subjected to the magnetic field, electron energy level of the atoms or molecules will split in different level. The magnetic of splitting depending on the strength of applied magnetic field. Magnetic of splitting depend strength of applied magnetic. Which one is applied magnetic? Electron observes microwave which undergoes to spin transmission. So that is very important. We are talking about the molecule having the one unpaired electron kept the magnetic field B naught. When number of magnetic field B is equal to 0, both of the spin state of electron degeneration means for ms equal to plus or minus of same energy. When the magnetic field is applied, beta is greater than 0 in case of two states split into two different level. One is a beta is minus of, another one is a plus of. So ms is plus or minus of. So we get the delta E is equal to h nu. There are the two splitting is possible. The magnetic spinning is plus of spin and ms is equal to minus of spin. That is called as a beta spin, alpha spin. Then the transition occur that electron transfer from beta spin state to alpha spin state, which means to undergoes to resonance. So the detector will be detected this electron transmission, then produced speaks delta E is equal to G nu B bu and B naught. Nu B is equal to Bohr magnet, B naught is equal to strength of magnetic field. So G spectroscopic splitting factor. So this is the formula. The delta E is equal to G nu B naught. Once again, delta B is equal to Bohr magnet, B naught strength of the magnetic field, G is spectroscopic splitting factor. Derivatives curves. So here's a spectrum or spectra commonly present in derivative curves. The slope of absorption curve is plotted against the strength of magnetic field. So here the flatted signal versus to magnetic field strength G. Here observed in absorbent first derivation. In case of ESR spectrum, the spectrum absorption signal is broad and it is difficult to know the point of maximum absorption. The recording of spectra as a derivatives is useful because of helps to identify the point of the maximum absorption, which is obtained as a point of intersection of the two lines. So this is for the very important to ESR spectroscopy. We are finding the two absorption signal brand. Here another one important theory for G value shift. What is G value shift? Length, G splitting factor, G shift ESR, and then NMR is chemical shift. ESR is G shift, NMR is chemical shift. ESR often used to investigate the system in which electron have the both orbital and spin angular momentum, which necessitates the use of scaling factors to account for the coupling between the two momenta. This factors is the G factors. G value for the free electron is GE is equal to 2.0023, but the other chemical species like organic radicals G values varied. G shift delta G. What is delta G? Delta G me is equal to G minus GE. G is equal to GE minus bracket A square n lambda divided by delta E. Here the lambda is spin orbit coupling constant, A is covalent parameter, n is equal to quantum number. By this equation, calculation of the exact value of G. Case 1, the organic free radical delta E is equal to delta E minus high, lambda minus low, and case of 2, the transition metal delta E minus low, lambda is high. So this is for the G shift delta G. Coupling field orbital, positive delta G. Coupling empty orbital, negative delta G. So GE form as a basic on the other system, same as NMR, like TMS in this NMR. So example, the transition metal complex, if it is less than 2.0 complex in electron poor, high oxidation state. If it is more than 2 complex, it is electron rich, low oxidation state. So this is for the ESR spectroscopy, very important to transition metal complex. Very important of ESR is G factors, G shift is very important. So today we are going to discuss about the what is ESR spectroscopy, definition of ESR, theories of ER, instrumentation of ESR spectroscopy, derivatives curves, and G-shift. So ESR is very important. So this is for the theory and instrumentation, derivative curves, G-shift. Please students, watch this video and learn this video. Thank you.